Hello and welcome to the Dickville security channel. I have not produced a video publicly on here for a couple of years, so I'm making a bit of a New Year's resolution to do a little bit more this year. I'm going to try and do one a week. We'll see how that goes. I've basically got about 150 tabs open on my mobile phone and all these cool tools that I want to play with, so that I've picked up over the last sort of like 18 months that I haven't really had time to do. So now I'm going to try and put some time aside and jump straight back into where we left off 2 years ago with some advanced data exfiltration techniques. This is going to be using today a tool called CloakifyFactory. This is an awesome tool basically for a bit of data loss prevention, evasion. So you might have some hardware on the network which is inspecting the data as it goes across the wire, as it goes out to the internet, looking for things like credit card numbers, rows in databases, things like that. And so what this tool does is it obfuscates the data so that you can send it out to the internet and hopefully evade any signature-based detection and even inspection by an analyst. So what we're going to do basically, this is our Kali attack box here. We've got a victim system running Windows 7 over here, and basically we're going to assume compromise. I'm going to generate a meterpreter payload. We're going to assume compromise over here and have the victim execute it, getting our meterpreter session back to here, at which point we're then going to upload the tools that we need in order to carry out this exfiltration of data that we have discovered on the victim. That will then go out to a box on the internet, and once we've got it out here onto the internet, we will then decloak that data and the exfiltration of the data will be complete. So let's jump straight in and generate our MSF payload. I'm going to do a x86. We know it's a Windows box. We're going to go for a reverse TCP interpreter. This is just across the local network at the moment, so we've got some 192 addresses, 5.140, using my favourite port. That's just how you get rid of bad characters, so we're getting rid of null bytes from this payload basically. Shouldn't matter too much, but it's just a nice little technique to know about. And we're going to encode it with our old favourite, make it into an executable format, and we're going to call it something tempting. Bitcoin wallet 2015.exe. Who wouldn't want to open that? So let's generate that. So once this is generated, we're going to dump it into the web server on this box. So let's make sure that Apache is running. Yep. Okay. I'm going to move this into our web directory. And let's go grab that on the victim, and then we'll come back and set up the listener and stuff. So Bitcoin 2015. Obviously, it's going to pick up that it's an executable. It's a bit dodgy. We don't have any AV on this box, so we're not going to fire any AV signatures. If we did have, and we wanted to evade that, one of my old talks, I talked about using Veil, so you can encode, you can encrypt payloads so that they will evade antivirus. Okay, so there we go. We've got it on the desktop now. You can see I've been doing some testing earlier. So that payload is now ready to be executed, and it's on the desktop of the victim. We need to obviously jump into metasploit, set up our listener to catch that session as it comes back. Yeah, I haven't got the metasploit database running, but that's no worries. Okay, so obviously we need our exploit multi-handler in order to catch the connection as it comes back. Using the payload interpret reverse TCP. We know the L host. And we know the L port. So we should be able to go and run that now. There we go. So we've got a handler running on our favourite port. Let's go and execute this. Ignoring all warnings because it's got some juicy bitcoins in it, hopefully. Oh, nothing's happened, surprisingly. But if we go back here, we now have an interpret session. So let's interact with this session. And there we go, we're on the desktop. And there's the file that the user executed. We could delete that now if we wanted. It's no longer needed. The user might think that's suspicious anyway, but there you go, permission denied anyway. But yeah, I'm sure I could force that, but it's not really necessary. So obviously this tool, there we go, is a Python framework. No, well, it's just a few Python scripts basically. The developers say if you want to run it on Windows, if we don't have Python, use py2exe. I did have a play with trying to get py2exe to compile this and had a bit of a nightmare. So what I'm going to do basically is go about it a different way, which sometimes we have to do as security guys and girls, and basically get Python installed on the victim instead. So let's background this session, and what we're going to do is we're going to grab an MSI of Python off the internet, upload it to our victim, install Python on there, and then we can get our scripts up there and start executing them. So first things first, we need to grab Python. So okay, let's upload this. Give that a couple seconds to upload. Okay, now we have that uploaded. Let's go back into our shell. And you can see it there. What I'm going to do is jump over here, just prove quickly that Python is not installed. Yep, no Python. Jump back over here. So what we can do now is we can do a command line installation of this Python. Type it out again. And /qn means no dialog boxes or anything, because else, if I didn't put that qn on there, we'd have a dialog box pop up here, and obviously we don't want that. I mean, we're being quite noisy already. We could be dumping this into temp directories and things like that to try and evade the user's notice. You know, at the moment this is just a demonstration, but you know, let's be as quiet as possible. So /qn, no dialog box, off it goes. So over here, there'll probably be like yeah, there we go. So there was a brief pop-up, but now we can see that Python is installed, so we can continue our attack with the Python tools. Background this again. A couple more bits and pieces that we need now. We need a copy of 7-zip, because what we're going to do is we're going to grab the whole archive off GitHub as a zip file, So in order to do some command line zip operations, I'm going to get a portable copy of 7-zip. So again, I've got the direct URL here, 7zip.org. So this is a slightly older version than the current, but it does have exactly what we need in it. Just grab that quickly, unzip that, and this 7za.exe is the only thing that we need, so let's just upload that onto our box. In the meantime, let's go and grab this archive here. What I'm going to do is just download the zip. So I've got that URL, and it is, there we go. Grab that. 7-zip's now uploaded onto there nicely. So let's upload master.zip. Okay, master.zip now uploaded. Jump back into our shell. We've got some nice tools uploaded on here now. We've got Python, we've installed that. We've got the master.zip containing the Python framework that we're going to need, and we're going to extract that with 7-zip. So 7za.exe, X for extract, master.zip. And there we go. We now have Cloakify on the box, ready to start exfiltrating some obfuscated data. Right, what we need next are some files to exfiltrate. So let's go have a poke around. Always have a look in the users directory. There's always something juicy in there. SQL, that looks convenient. My records. Oh, couple nice little files in here. Test file. lizarddb.csv. Oh, there we go. Some juicy data. We've got obviously a database table, some usernames, some passwords in plain text, some email addresses. What this actually is an extract from the lizard stressor database, which itself was compromised. People were obviously paying for denial of service operations using lizard squad's lizard stressor. It itself got compromised. They dumped the list of users that paid for that illegal denial of service. And this is an extract that I just grabbed off paste bin. So if your name's there, I'm sorry. Okay, so there we go. There's our data. That's what we're going to exfiltrate. If we try and did that over the, if we were trying to do that over the wire, and there was some data loss prevention tools in place on the host or on the network, we might get caught. We might get caught by the SOC. People, this gets flagged. People investigate that data. So we need to make this look not like this. So now that we've got Python installed, we can execute CloakifyFactory.py, which is the main command that you call, which does all the framework operations that we need. Unfortunately, this doesn't seem to work. It doesn't play nicely on the command line. It's not popped up anything over here, but I think what it's trying to do is spawn another terminal window, which we can't catch. So I'm going to terminate this, and of course there's always another way. And luckily for us, the guys thought of this very case, and there is a method of using standalone scripts, Cloakify and decloakify. That's what we're going to do here. Rather than using the framework to do it in more of a wizardy guided fashion, we're going to just do it with the standalones themselves. So we need our Python binary, and we need Cloakify. So what does Cloakify do? It needs a payload file name. That's the file name that we're going to encrypt, or encode, and we are going to encipher it. And it needs the file name of the ciphers that we're going to use. So there's lots of different types of cipher that we can try. We've got these are all the packaged ones. You can make your own. The instructions on how to make your own here. Pokemon Go monsters, so it makes the data look like a list of Pokemon Go, ski resorts, small cipher space, AV evasion. But what we're going to try for is world beaches. We're going to try and make it look like someone's weird holiday planning route. So, Cloakify.py. So the payload file name is going to be our SQL file that we found earlier. Here we go. My records, and it's called lizard_db.csv. And it needs a cipher file name. So we're going to go for world beaches. In the documentation it says use world beaches. Let me just show you. There's a slight mistake here. Yeah, see, it always says put .ciph on the end. That's incorrect now. Maybe that was a previous version, but now there's no extension. So we need an out file for that. So I'm just going to call this holiday routes 2018.txt. So there we go. Simple as that. That data has now been encoded into a list of beach names all over the world. We could just leave it like that and bosh it out through whatever method to get it onto our cloud server. Instead, I'm going to add a little bit more random data on top of it, a bit of what they call noise in this tool. We're going to use we need our Python binary again. So let's see, Python. So we're going to prepend the latitude and longitude coordinates to the front of our file, basically. Off it goes. So now if we go and look at this, it's now got a load of latitude and longitude in front of it. I mean, you know, it looks a bit more like it couldn't really be obviously suspicious. It's just a load of beaches with random latitude and longitude coordinates. I think that'll do for our. You can prepend. Let's go and have a look in here. Just to quickly show you the other types. So we can put ID. We can put timestamps or random emojis. I did play with the emojis one just to, but yeah, we don't necessarily need that in this case. So now we need to get this data off of here. So I'm going to move Cloakify master / holiday routes 2018, which is our data to be exfiltrated, to here. So it's now on the desktop. If we go back to our victim, we can see that all this stuff's been going on over here as well. So we've got our data ready to be exfiltrated, and we're going to do that using Netcat, so that we can get it straight out to the internet. Right, what we need to do is let's go and I was going to locate it, but let's just background this. Upload. I think I can remember what it is. User share Windows binaries. Yep. Let's get Netcat onto the box. Again, look at the victim. We can have some Netcats on there. Again, that may trigger a AV alert in the real world, so you know, be careful with Netcat. You know, there's alternatives. What we're going to do now is go to our internet staging ground. over here. Let's listen on one of my other favourite ports, and we're going to pipe anything that comes in on 1337 into the file exfil.txt. Let's go back to our shell. So we've now got netcat ready to fire the data out to the internet. I've added a entry in the host file for the IP address of my external server, and so effectively that should be all I need to do. Holiday routes 2018. Sorry, I've messed up that. I need to put the port in, obviously. Now that should theoretically be exfiltrating that data out to the internet. Let's have a look. So we got 192,723 bytes, and that matches up nicely to that. So we have successfully exfiltrated that data out to our server on the internet using netcat. Now, that data obviously still looks like a load of random latitude and longitudes and beach names. We need to now uncloak that data and get it back to a nice juicy database table. So I had a big problem here earlier on when I was testing with this. I made the stupid mistake of not realizing that this would have a lot of Windows control characters on it because it was generated on Windows, so I wasted some time trying to debug the Python scripts, and really all I needed to do was just simple DOS to Unix on the exfiltrated data, knocks off the Windows control characters off the end of the lines, and allows us to work with it properly on Linux. Okay, now that's done, what we're going to do, so our exfiltrated data has 2 columns of noise. So what we need to do is we need to remove that noise. So luckily they've included a nice little script here. So number of columns to strip 2, noisy file name exfil, output file name ready. Ready as in ready to be converted back to legitimate data. Let's now have a look at ready.txt. That should have stripped off. Yep, so we're left with just the beach names. Previously, obviously, you can see that it was yeah, obviously looked like that. Now, it's literally just a case of decloakifying the data using the same cipher that we created it with. And there we go. Data exfiltrated in plain text, in plain sight, from a server to a server on the internet. And once we've got it back, we've decrypted it back to the juicy data that we wanted out. And that's pretty much it. Simple video just to ease me into the year. Sorry, I've got a bit of a sore throat and a bit of a cold at the moment, but hopefully that hasn't put you off too much. And yeah, I look forward to doing a lot more videos this year. Thank you very much.